Hi, in this video we're going to look at the basics of parabolas, what a parabola looks like, how we go about drawing it. Now, the most basic way to draw a parabola is to draw it from a table of values. In order to get your table of values, we're going to use a graphics calculator. Now, if we take a basic parabola, something that looks like this, y equals x squared minus 2x minus 3, we want to see what that looks like, and we need to get a table of values. So we need to get a table that will show us the relationship between our x values and our y values, and we need to plot those. So go to the table function by pressing your menu button on your calculator and then choosing the option that gives you table. Now, my calculator is the number 7, but it might be something different on yours. So have a look and find out what it is. Press number 7, and there's the table function. Make sure that the top of the table function that it says y equals. If it doesn't say y equals, then go to the F3 button, which is the type of equation, and you can write the equation in different formats over here. We're concerned about writing it as y equals, so I'd press the F1 button, and then you will see we got y equals up top over there. Now, I've got an equation in there already which I'd used before sometimes, so I'm just going to delete that. In order to delete it, press the delete function, which is the F2 button. It asks if you want to delete the formula, press F1, so yes I do, and there you'll see it's deleted. Now I'm going to enter the equation in. I'm going to use this button over here, the button below the red alpha one, to give my variable x. So press x, and I'm going to square it, minus 2x minus 3, and then press execute, and you'll see that you have now entered the equation in onto the calculator. To see what the table of values looks like, you simply go to the table function, which is on this menu at the bottom of the screen over here on the extreme right hand side, TABL for table, press F6, and there we got the table of values. Now you will see this table of values isn't very long. It only goes from x is 0 through to x is 4. So I need to amend that. In order to do this, just exit out of here briefly, and on this menu at the bottom of the screen you'll see it says set over here under F5. That allows you to set the values that you want to see in the table. I'm going to start my table at minus 4. I've got a double minus, I don't want that. Minus 4, and I'm going to take it through to 4, and each time I'm going to jump up, I'm going to step up by 1. So put that in there, and I can now exit. If I go back to my table, pressing F6, we'll now see that we've got a table of values over here that goes from minus 4 through to plus 4. Now we'll see that some of those are actually getting very big, and I don't know that I'll be able to draw those, plot those accurately enough, but the other ones I should be able to get through quite nicely. So I'm going to take my table of values from minus 2. So when x is minus 2, y is going to be 5. When x is minus 1, y is going to be 0. Keep scrolling down. When x is 0, y is going to be minus 3. When x is 1, y is going to be minus 4. When x is 2, y is going to be minus 3. We go on down. When x is 3, y is going to be 0. And the last one, when x is 4, y is going to be 5. Now, interesting, you can note over here that we've got some symmetries happening. Those both have the same y values. These ones both have the same x values, same y values as well. These ones also both have the same y values. Now this shouldn't be too surprising because, as you remember from last year, a parabola is symmetric, and so we're expecting to see values that are going to be repeated like this. So now we're going to see what this looks like when we draw it. I've got a set of axes drawn up over here, and I can now start plotting these points. So the -2 and the 5 are coordinate pair. I can plot them. There's that point, -2 on the x-axis, 5 up on the y-axis. So there's the point -2, 5. Get my next point, which is -1, 0. That's over here on the x-axis, where x is -1 and y is 0. Then I go and plot when x is 0 and y is -3. It's this point down over here at C. I then go to point D, which is the point point 1, -4. So I've got 1 across and 4 down. I then go to point E, which is the point over here, 2, -3. The point F, which is my point over here on the x-axis again, 3, 0. And my last point, 4, 5, which I'm going to call G. And here we can see that we've got 7 points now, and that gives us a rough idea of what the curve is going to look like. And in fact, a line can be drawn through those, and there is the curve of the parabola. So here's our basic parabola. I've just made a copy of that diagram, and we've got this very distinctive U shape, which we always associate with a parabola. These points over here are important. They are what are referred to as the roots of the graph, or you might call them the x-cuts, because where they cut the x-axis. Likewise, this point over here is called the y-cut, or the y-intercept, because it's the point where the graph crosses the y-axis. Now, we remembered when we were drawing up these points that there was a line of symmetry that ran down the middle of the graph. The line of symmetry appears to run down here, down this line over here. This is the line x is equal to 1. And the graph is symmetrical around that line. This point that we have down the bottom over here, the point at D, is an important point because that's our turning point. Sometimes it'll be called the maximum point or the minimum point. In this graph, it's going to be called the minimum because it's the lowest value that the graph reaches. But if the graph was the other way around, then it would be the maximum point. So those are the key features or points that we need to get from the parabola when we're drawing it, and we can get those points. And we can get those points drawn by using the table function on the graphics calculator to draw the graph for you. So we will talk about features of the parabolas in a later video, but this is just a basics introduction to parabolas so that you can see what the shape of the graph looks like. Hope this helps. Goodbye.